Hey guys, welcome to another lesson with Arduino on Tinkercad. I'm Mr. Riaz. I hope last week you had some luck trying out the light detection resistor sensor, and I hope you managed to get the codes to work. I can see by some of your submissions on SLS, your pictures and your videos, that some of you were successful, and I hope from there you can play around with it and see what else you can do to modify it to make a device that's going to be interesting for our own personal projects. Okay, so today we're going to move on to another sensor. Today we are going to be using an ultrasonic sensor, which is using a sound sensor, okay, like a mini sonar. Okay, and we are using it to calculate the distance of objects. Okay, last week we already talked about what are sensors. Basically, they are just devices that are able to detect and measure any physical property, and then we use any of this data that we collect, and then we use it to build an app or an application, okay, that is going to be very useful to us. All right, and we also talked last week about the different kind of sensors that are available that we can use with Arduino, like your measuring of your soil moisture, how much water in the soil, or you can even have your humidity sensor here and temperature, where you can measure temperature and how much water vapor is in the air, and among other things. And one of the sensors that we talk about is this thing called the ultrasonic sensor. So today we're going to learn a little bit more about what is an ultrasonic sensor, and then we are going to use it in our project, okay, to build an application. All right, okay, to see what we can do with it. All right, so what are actually ultrasonic sensors? Okay, basically the model that you often see is this HC-SR04, and basically it's a sensor that uses sonar to determine the distance to an object. Okay, just like bats, they will emit a sound, and any of these sounds that reaches any object, it will bounce back to the bat, and then the bat is able to measure any objects that are in their way while they're moving or they're flying. Okay, so this thing, as you see here, is your ultrasonic sensor. Okay, so hopefully when we are back to face-to-face classes, okay, to our normal CCA classes, we should be able to handle this, because this is in the kit that I'm going to be providing this year. Okay, and this sensor is able to read any object that are between the distance of 2 centimeters to 400 centimeters, up to 4 meters, and the accuracy of it is around 0.3 cm plus or minus. Okay, and the good thing about this sensor is that it comes with both the the transmitter that gives out the sound. At the same time, any sound waves that are being bounced back, you can also receive from the same sensor. Okay, so how does it work? All right, so ultrasonic sensors basically is just a basic sonar, like the bat example that I gave you earlier. Okay, so you can actually can transmit using the trigger pins to emit a high frequency sound that's about 40 kilohertz, so we cannot hear the sound. Okay, and this sound travels through the air. So from the transmitter, it will transmit the sound. Okay, if you look at the diagram, it will travel through the air, and once it hits any object, this sound wave will bounce back from the object and back to the receiver of the sensor. Okay, so the echo pin in our sensor will receive the bounce back or the echo, and then because we actually know the time it takes for this sound wave to be given out from the transmitter, and then how long it takes to come back, okay, because we know the speed of sound, okay, which is a fixed number, it's a constant. So from there we can actually calculate what is the distance. Okay, and don't have to worry, because the Arduino library does all the calculation for you. Okay, all we need to know is how just to set up the sensor, and then what kind of data this sensor will return back to you. All right, So if you look at the sensor here, you can see there are 4 pins here. Okay, these are the main pins. Okay, your VCC basically is your power, your 5 volt. Okay, and your ground, of course. And then you have 2 other pins there. One's your trigger, which is what you're going to input to send out the measure the to send out the sound wave, to measure the distance, to give out the sound wave to bounce back. And then the echo, which is the echo pin, which is to receive any of the sound wave that is bouncing off the object and coming back. Alright, so once it's done, then we can actually use this data to create something in our application for the Arduino. Okay, but in Tinkercad, however, later on when you are trying it, you will realize that in the Tinkercad, the ultrasonic sensor has only 3 pins. Okay, this is because for this sensor that you can find in Tinkercad, they are using the transmitter and the receiving pin as the same pin. Okay, so for the ultrasonic sensor on Tinkercad is a little bit different from the actual one that you're holding. So don't worry about it. You just need to follow my tutorial later on, and then we can and see how it goes. Alright, see whether you can build your app. Alright, so for those students who are still unable to get to the class, because last week I see that some students who are not able to, so this is the code for the class, which is still the same. And then when you go into your SLS later on, you can go and find out all your different nicknames if you're not able to log in yet. Okay, so just find your nickname and then join the class using your nickname. Okay, so let's not waste time with any more jibber jabber. So let's get on to our lesson for today. Alright.